Hi, I'm Beatriz Jesus Feres. This is my video module for MSc 215 class, and I'm gonna be talking about the aluminum foil. So I'm gonna start off with an introduction talking about what it is, what is made of, performance requirements, and the properties to meet these requirements. Then I'm gonna move on to the history, talk about the foil itself before the aluminum and the first aluminum foil. Then I'm gonna move to the process that is, in this case, flat rolling. Talk about other processes, microstructure and properties, and how the processing affects it. And then I'm gonna show the homework problems from the textbook. So aluminum foil has a composition of 1,000 series. That means it's almost pure aluminum, but sometimes you have some impurities in that. The performance requirements are to be inexpensive, be a good barrier to oxygen, light, odors and flavors, moistness, and germs. It has to be flexible, safe to cook, and low weight. The properties to meet these performance requirements are impermeability, formability, so it has to be able, like you can fold it, smash it, whatever you want to do it with it. So it has to be non-toxic, corrosion resistant, temperature resistant, and has a good heat conductivity. So before the aluminum, foil was made from a thin leaf of tin, and it was commercially available before aluminum from the late 19th century until early 20th century. The term tin foil survives in the English language as a term for the newer aluminum foil. Tin foil is less malleable than aluminum foil and tends to give a slight tin taste to the food when wrapped in it. So in 1886, two scientists working separately in USA and France concurrently developed the Hall-Héroult method of separating alumina from oxygen by applying electrical current. In 1888, the first aluminum ingot was produced. In 1903, France became the first country to produce foil from purified aluminum. In 1911, Bern-based Tobler began wrapping its chocolate bar in aluminum foil, including the triangular chocolate bar Toblerone. In 1912, aluminum foil was being used by Maggi to pack soups and stock cubes. And in 1913, it was the first use of foil in the USA for wrapping lifesavers, candy bars, and gum. So how it is made? Extracting pure aluminum from bauxite involves two processes. First, the ore is refined to eliminate impurities, and the resultant aluminum oxide is melted to produce pure aluminum. After that, the aluminum is rolled to produce the foil. So I'm gonna talk a little bit more about these processes, the refining, the smelting, and the rolling. So I'm gonna begin with refining, and it has four different steps. And the first one, uh, digested, is the bauxite is ground and mixed with sodium hydroxide and pumped into large pressurized tanks. In these tanks, the combination of sodium hydroxide, heat, and pressure breaks the ore down into a saturated solution of sodium illuminate insoluble contaminants, which settles down in the bottom. The solution of contaminants go through a set of tanks and pressers. Cloth, cloth filters trap the contaminants, which are then disposed of. After being filtered again, the remaining solution is dropped into a cooling tower. The aluminum oxide solution moves into a large silo, where the fluid is seated with crystals of hydrated aluminum to promote the formation of aluminum particles. As the seed crystals attract other crystals in the solution, large clumps of aluminum hydrate begin to form, and these are first filtered out and then rinsed. The final step entails exposing the aluminum hydrate to high temperatures, and this extreme heat dehydrates the material, leaving a residue of fine white powder, the aluminum oxide. So now the smelting process is basically taking the aluminum that it was refined on the process that I've talked about, and dissolving to a molten cryolite at 1,000 degrees Celsius. This seems like an extraordinarily high temperature until you realize that the melting point of pure aluminum is 2,054 degrees Celsius. So adding cryolite allows the electrolysis to occur at a much lower temperature. The electrolyte is placed in an iron vat lined with graphite, and the vat serves as a cathode. Carbon anodes are immersed in the electrolyte. The electrical current is passed through the molten material, and at the cathode, electrolysis reduces aluminum ions to aluminum metal, and at the anode, carbon is oxidized to form carbon dioxide. The molten aluminum metal sinks to the bottom of the vat and then is drained periodically through a plug, where it is taken to the primary casting. Now about the rolling process. After the foil stock was made, it must be reduced in thickness to make the foil. This is accomplished in a rolling mill, where the material is passed several times through metal rolls called work rolls. As the sheets of aluminum pass through the rolls, they are squeezed thinner and extruded through the gap between the rolls. The work rolls are paired with heavier rolls called backup rolls, which apply pressure to help maintain the stability of the work rolls. This helps to hold the product dimensions within tolerances. The work and backup rolls rotate in opposite directions, and lubricants are added to facilitate the rolling process. During these rolling processes, the aluminum occasionally must be annealed to maintain its workability. The reduction of the foil is controlled by viscosity, quantity, and temperature of the rolling lubricants. The roll gap determines both the thickness and the length of the foil leaving the mill. This gap can be adjusted by raising or lowering the upper work wall. Rolling produces two natural finishes on the foil, the bright and the matte. The bright finish is produced when the foil comes in contact with the work roll surface. To produce the matte finish, two sheets must be packed together and rolled simultaneously. When this is done, the sides that are touching each other end up with a matte finish. As the foil sheets come through the rollers, they are trimmed and slided in circular or razor-like knives installed on the roll mill. Trimming refers to the edge of the foil, while the sliding involves cutting the foil in several sheets. So I have a little video to show the rolling process itself, but I figured out that I can open on the presentation, so I'm gonna go to YouTube very quick.
The many steps in the thinning of the ingot begins. The aluminum block is crushed by the hot mill rollers. Temperatures in the rollers are between 455 and 540 degrees centigrade. Pressure on the ingot is continually verified by a technician. If too great, it's lowered and the technician then adjusts the pressure. The heat is so high that the ingot risks sticking to the mill's roller. To prevent this, everything is cooled with a liquid that's 95% water and 5% oil. Starting from a thickness of 45 centimeters, the ingot becomes increasingly thinner with each pass-through. Depending on requirements, the ingot will go through the machine between 12 and 16 times. The ingot now measures 7 centimeters in thickness. It has to get down to just half a centimeter. At this stage, the ingot is 5 centimeters thick and measures a little over 9 meters in length. This conveyor transports the plate during its milling stages. The ingot has now become a 5 millimeter thick sheet. It is sufficiently thin to proceed to spooling, where it spools onto itself before being sent to the cold rolling mill, where its thickness will be reduced still further. The aluminum sheet has become very thin now and risks being broken by the tension needed for cold rolling, so the sheet is doubled to avoid this breakage. One final reduction in the mill, and the sheet will have the thickness required by the customer. A liquid coolant is used to prevent the foil from sticking to the rollers. Since the edges of the foil sheet are lightly damaged and crinkled, a knife removes a 1 centimeter thin strip. Finally, the roll is cut to the desired width, and one huge ingot has produced foil measuring 12.7 kilometers in length.
So that was the rolling process. Now I'm gonna talk about other process. I really had a hard time to think about other process techniques to aluminum foil, because rolling is a pretty basic process and it's one of the first steps to produce other objects, metal objects as well. But I've read on the textbook roll mills dated from the 14th century, so it is something really old, and I really couldn't think about anything else to put on it. The only thing I could think of, and I found actually, was different process to refine and smelt the bauxite and the alumina, but not the rolling process itself. And how does rolling process the microstructure of the metal? Um, the decreasing material thickness causes the material to elongate. So we can see here that grains are deformed and they are not equiaxed anymore, they are directional, and that's how it affects. And how it affects the properties. So most of the rolling is carried out by hot working, so due to the large amount of deformation required. So the raw rolled metal is generally free of residual stresses and its properties are isotropic. The disadvantages of hot rolling are that the product cannot be held to close tolerances and the surface has a characteristic oxide scale. The chapter that talks about rolling in the textbook is the chapter 19 under the section 19.1, and I talk more about flat rolling and not about shaping and rolling mills. The three homework problems that I chose are these ones: a review question, a multiple choice quiz, and a problem. In summary, aluminum foil is prepared in thin metal leaves with a thickness less than 0.2 millimeters. The foil is pliable and can be readily bent or wrapped around objects. Its popularity will continue to grow because of flexible packaging and the fact that the raw material necessary for its manufacture are plentiful in the Earth's surface. The manufacturing process involves three steps. First, the ore is refined to eliminate impurities such as iron oxide, silica, titanium, and water. Then the resultant aluminum oxide is melted to produce pure aluminum, and after the aluminum is rolled to produce the foil. These were my references and the textbook as well. I don't know why it's not here. I'm sorry about that. And this was my presentation. I'm sorry about the bad English. I was really nervous, and thank you for watching.